Hello, in this video we are going to see static methods and how it works. In the previous video we saw static data member. This time we are going to see the static method. So like static data members, static method can be invoked without creating instance of the class. So the only difference is previously we called a static data member. This time we are making a function call which is a static. So like a static data member, the static method can also be called using the class name. Alright, since the static method does not belong to a particular instance, that means the instance is the static method is not belongs to any specific instance. It belongs to the class template itself. So since it does not belongs to any particular instance, we do not have this reference in the static method. So in static method, if you specify this, then inside the body we may not know what this reference refers, because since it's common for all instance, so we don't know which instance to refer. That's why this is not valid inside the body of the static method. So inside static method, one can access only the static members. So the static member can be a data member, or it can be one more static method. So we can make a call to another static method inside one static method, or you can access a static data members. But you can't access instance specific member. That means a member, whether it is a data member or a function member, if it is not marked as a static, then we can't access those members inside the static method. So simply static method can access static data member as well as other static methods. Static methods are useful to write utility functions. So utility functions does not require any object state. For example, let us say this function called square, and it takes a parameter int x. So this function will square the given number. So if a given number is 4, then the aim of the function is to return 16. If it is 10, it will return 100. So the operation will be multiplying the parameter with the same number and return the data. So here it absolutely doesn't depend on the instance specific member. So this function is a good candidate for a static method. So it can go inside a math class. So once we have square as static inside the math class, outside the math class we can use that as a utility function. That means any class can call math.square, then it can pass an integer literal or integer variable to get the square result of it. All right, let us see this with an example. So here in the math calc, we defined a const called phi. So the keyword public states phi can be accessed anywhere. It means inside the class we can access, or outside the class also we can access it. Next comes the keyword static. So here we state that the variable pi, or we can say it's constant, since we specified a final next to the static. So the public, we already talked about it. Static states that phi is a static data member. That means outside the math calc, one can easily use this constant. Let's say some outside code is calculating area of the circle, they can directly refer this phi as a math calc dot phi. So the final keyword stops changing the value. Finally, we specified the data type float. So here there are 3 modifiers and 1 data type, which is specified before the phi. Float is the data type. Finally, is a modifier which states that once phi is defined, it cannot be changed. Static states that the phi is not instance specific, this is a class specific. Then public states that phi can be accessed anywhere. Next, inside the math class, we are defining a function called square. So this method calculates the square of the member. The member is stateless and completely depends on the parameter x. So here if you see, the method does not depend on the state of the math calc. So depending on state means if the method square access any of the non-static data member, then we can say the square is stateful. That means it depends on the state of the math class, and different instance may have a different value for its dependent data member. Right here in this example, if you see, it doesn't invoke any internal member. The parameter passed is x, and that is multiplied here x into x, and that's returned to the caller. So it's completely doesn't depend on object state. So that's why we keep it as a static here. So square is a static method. One can access this method outside the class just by specifying the class name. For example, math calc dot square of 10. Like that we can call outside this class. Next we have one more static method, which is called circle perimeter. So the incoming parameters are here. We are making use of the static member phi. Since the member is static, it can be accessed inside the calc circle perimeter. Also, if you see here in the circle calc perimeter, we access the file, and it doesn't specify math calc here because we are accessing it from inside the class itself. So the calc circle perimeter is in current class scope, so we directly access the file inside it. Since this method is static, we can access the static member, but we cannot access a instant member inside this calc circle perimeter. Alright, this function calculates the perimeter of this circle, then it returns back. Next, if you see, we are using a calc circle, and this makes use of both the static member. Here we are using the static data member file, as well as we are using the static method square inside the calc area. Then we are returning the result. So this final function proves that since this is static, it can access a static member. The first one phi is a static data member, and the second one is a static function. Okay, we will explore this in Eclipse now. Here is the Eclipse, and we have both the classes. First, we will go with the MathCalc class. So in MathCalc, first we defined our static data member phi. Then, as we saw in the slide, we have a function called square, which calculates the square of given number x and returns back. Then calc circle perimeter, this one accesses the internal phi and returns back to the caller. In snippet 4, you are seeing calc area. This static method accesses both static member phi and square. I mean, this is method called square r, and which is defined here. Now next, in the main class, first we defined radius as a 10. Then we are making use of the square function from MathCalc class. Here if you see, we are calling square on the class template name itself, MathCalc.square. So if you see here in the IntelliSense also, it shows what are all the member available without creating the instance. Here the S stands for static. So from here you can see the first one is the template, and the second one is a phi which we defined. This is a static data member. Then 3 functions are available. So without creating instance, we can access all these. All right. So next we called the perimeter function. So after that we are making call to the area of the circle. So we saw all this in Eclipse. Let us execute this. So here is the console window. I'm not going to step inside, you'll just step over and see. So first one called the square function, and you are seeing the result in the console window. Here you are calling circle perimeter. That result is printed. Then we are making call to square function. All right, now let us see the errors. What happens if we access a non-static member? Say, for example, int t. Now, let me try to access t here. So here in the problems tab, you can see that error. So it says that cannot make a static reference to a non-static field. So which one is non-static field? So here T is the non-static field. That's what it is complaining here. So the same goes for non-static method also. Since this is a static method, if you make a call to a non-static method here, you will get a similar error. That's all here. So here phi is template specific. That means it is specific to MathCalc, not a specific instance of MathCalc. Here if we create a MathCalc of object 1, object 2, object 3, then all the object shares the same data member phi. Similarly, all can make a call to square using the object itself, obj1, obj2, or they can even call it with a class template name itself, mathcalc.square. So we already saw that. This is also possible, math. So we can access all the static methods using the object created here, W1. But what happens if you have multiple objects, then all will share the same data member. That means the same static data member. All right. People usually create an instance like whatever we saw just now, when the method has non-static member. It can be a data member or function member. So that time one will end up in creating the instance. Then they can access the static member using the instance name itself. But even though they access it through instance name, the static data member is not instance specific, it is template specific. That's why we say all instances of a class shares the same static data member. Okay, let's go back to our slide. So that's all here. In this video we saw what is a static method, and in the previous video we saw what is static data member. Thanks for watching. See you in the next video. Bye bye.